Hello guys, welcome to Right to Do. So today we are solving the Leetcode POTD sort colors. It is a medium level question. Let's read what the problem statement says. Given an array nums with n objects color red, white and blue. Sort them in place. Okay. We are given a nums array. So we can say that we are given a one array A. Let me name it as A. Namely color red, white and blue. Okay. So color is red, either red or white or a blue. Three colors. Sort them in place so that objects of the same color are adjacent and which the colors in order of the red, white and blue. Okay, we have to sort in this manner, and red is denoted as 0. We said that we will use the integer 0, 1, 2 to represent the color red, white and blue respectively. So red is 0, white is represented as 1 and blue is represented as 2. Okay, you must solve this without using the library sort function. Okay, you must solve this problem without using the library function. Okay, there is a library function in C++, is a sort function base of the array. Okay, in an increasing fashion or decreasing fashion, but we are asked to solve without this inbuilt function. Okay, so uh, let's say the first example test case 202 110 110. Okay, so we have to sort them 0 0 1 1 2 2. Okay, you know this. Okay, sorting things. So without using this inbuilt sort function, you have to sort this. So first option that you can use is you can use the any of the sorting algorithms. You can use any of the sorting algorithms code to sort this array. Okay. Uh, for the n is goes up to 300, n is goes up to 300, then you can run either order of n square or you can also run in order of n log n also. Okay, so merge sort or quick sort, your time complexity is order of n log n, while the insertion sort, bubble sort, they all techniques are using the order of n square time complexity. Both are accepted. Okay, not a question about it. You can find the code in any of the well-known internet platforms. Okay, these are the most known sorting algorithms. Okay, quick sort, merge sort, insertion sort, bubble sort. Okay, but for now we are solving the most optimal way. We are solving this question by most optimal way. What is the most optimal way? Most optimal way, there's the this n log n is we are traversing the array by ones. This is the order of n time complexity. This is the most optimal way to do the sorting of the three elements in an array. Okay, so this algorithm is known as the Dutch national flag algorithm. Dutch national flag algo. Okay, Dutch national flag algo. What is a Dutch national flag algo is about? Let's say I have an array. I will store my three pointers. Okay, there is a one pointer is low, another pointer is mid, and another pointer is high. Okay, while my while my mid is less than or equals to my high. Okay, while my mid is less than or equals to my high, then what will I do? My low pointer is containing all of the zeros. My mid pointer is containing my all of the ones. Means 0 1 2 means red, white and blue. But we are now comes to the integer terms, and high pointer contains the integers with the number of 2. Okay, so let's say if my current element, and I am only checking the mid element. Okay, if my mid element mid index element is equals to 0, then what is its correct place? Is its correct place is at the low. Okay, so I will swap my element to low. I will swap my element to low index and mid index. Okay, after doing this, I will increase my both pointer. I will increase my low pointer ahead by 1 position and mid pointer ahead by 1 position. Okay, this is all about if my mid index element is equals to 0. But if my mid index element is equals to 1, then it is on its correct place. Okay, because mid contains 1. Okay, this low contains 0, this mid contains 1, and this high contains 2. So if my mid contains 1, then it is already in the correct place. And what will I do? I will simply move ahead, and the rest of the things remains as it is. I will simply move ahead my mid pointer by 1. But if now else condition that if my mid does not equals to 0, does not equals to 1, then if my mid is equals to 2, then what will I do? Is it correct place? Is correct it correct place is at the high pointer. Then what will I do? I will simply swap my elements to the high. Swap my current mid index element to my high index element, and I will simply move my high pointer decrease by one. High pointer minus minus. Okay. Then why I will not move my mid pointer ahead? Before we are saw that we have seen that the mid pointer we are moving ahead. Then why we are not moving mid pointer ahead? Because at a high position, my high is a my high is containing the two. Okay, because my high element is swapping with my mid element, then I cannot make sure that my mid element is always contains one. I have to check in another loop that my mid pointer is containing a variable 0 or not. But if I am at the I will swap with my low position, then I have 100% guarantee that my mid pointer contains only one. Okay, because till the mid pointer 0 to till the mid pointer my every element is sorted. Then I will swap my element to the lower index element, then it is always equals to 1. So I have surety that here I have a mid index is always equals to 1 after swapping. But here I cannot make sure that my mid element after swapping is equals to 1. So I have to check in another loop that if my mid index element is equals to 1 or not. It is either 1 or 0. Okay. Anything can be happen. Okay. So this is the all about the national Dutch flag algorithm. Let's check for the dry run. 202 110 202 110. My low pointer is here, my mid pointer is here, and my high pointer is here. Okay, so what will I do? I will simply traverse through the array and I will check my mid pointer element. Okay, this is my mid pointer element is equals to 2. But what is the correct place of 2? Correct place of 2 is at a higher element, higher in the higher pointer. Okay, so I will swap this element by this. This is 0 and this is equals to 2, and then I will move my low pointer ahead by 1. This is my high pointer, sorry, high pointer ahead by 1. Then what will I do? I will now simple. Then high pointer is decreased by 1, but my mid pointer is at this position. Okay, I will not move my mid pointer because I have um, I told you that if this element is 1, I cannot make sure if this element is 1. You can see that this element after swapping is 0. So we have to check in another loop that mid index is either 0 or 1 or 2. Okay. So let's check that mid element is equals to 0. Then what is it correct place is correct. It correct place is at a lower pointer. Okay. Then I will swap it to lower pointer, but both are the same. Then swapping doesn't matter. Then I will simply move my both pointer ahead. Low, and here it's a mid. Okay, then my mid value is equals to 0. What is it correct place? Low. Swapping doesn't matter because both are the same pointers. Then I will move my both pointer ahead. Okay, now the mid element is equals to 2. Then what will I do? I will swap it to the higher pointer. 2 1 1 2. Then I will move my high pointer to its previous element. You can see that every index which are less than or equals to low and every index which are less than greater than or equals to high low uh, both containing the same element. Okay, low is taken care of the 0 and higher is taking care of the 2. Okay, and my mid pointer is taking care of 1. You can see now. Okay, now my mid element is equals to 1. Then what will I do? I will simply move my mid pointer ahead by 1. Then I will simply move my mid pointer ahead by 1. This is my mid pointer. Now my mid element is equals to 1. Then it is on its correct place. Then I will simply move my mid pointer ahead by 1. But when I will move my mid pointer is equals to here, then my loop condition is not satisfied because my mid element exceeding mid index exceeding my higher index. Okay, higher pointer index. So I will simply break my loop, and now you can see that this array is sorted after the iteration ends. So this is all about the Dutch national flag algorithm. Now comes to the time complexity. What is the time complexity and space complexity? Time complexity is we are traversing the whole array at most once. Okay, every element at most once. So time complexity is big order of n. And what is the space complexity? We are not using any extra space. We are only using this low, mid, and high integers. This will take constant space. So the space complexity is order of 1. Let's code it up here. Now, what will I first do? I will initialize n equals to a dot size. Uh, After that, I will initialize my 3 pointer. My low pointer is equals to 0. My high pointer is equals to n minus 1, and my mid pointer is also at 0. While my mid pointer is less than or equals to high pointer. if my element mid is equals to 0 and its correct place is at the lower pointer, okay, then I will swap my element to lower, and then I will increase my both pointers, because I have a surety that after swapping my mid element is always equals to 1. Else if my mid element is equals to 1, then what will I do? I will simply move my mid pointer ahead, because it is all on its correct place. Or else, if it is not equals to 1 or it is not equals to 0, then it is always equals to 2. Then what is the correct place of 2 at the higher pointer? So I will swap my mid to my higher pointer element, and I will move my high pointer decrease by 1. Okay. So when this loops end, then I will return my array A in place. Okay, so we don't have to return the array. Let's check it is running fine or not. Okay, calling the swap. Why the swap is not working? No matching function called to swap. Let's simply include the library. Let's include beats stdc++.h. Now let's run it. Okay, there is a no. This is not the issue. This is the issue. One curly, one brace is more. Okay, working fine. Let's submit it. Okay, accepted. Now comes to the time complexity. This loop is at max running big order of n. So the time complexity is big order of n, and space complexity is big order of 1, because we are only using these integers, which takes the only constant space. Okay, so this is all about the sort colors. Okay, thanks for watching. See you tomorrow.